Hello and welcome back to Assembly Language Programming. In this video, I'll explain how to write assembly language program to derive two 8-bit numbers in 8085. 8085 doesn't contain any specific instruction for performing division operation. So division must be performed by repetitive subtraction method. So let us consider two numbers. One in the memory location 8500, that is there, and then in 8501. So here 3 is called the divisor and 15 is the dividend. Now we have to perform a repetitive subtraction. So 3 and 15 are hexadecimal numbers. So the equivalent of 15 hexa in decimal is 21 and 3 equivalent hexa in decimal is 3. So the subtraction has to be performed until there is no carry. So it performs 21 minus 3. Next is 18 minus 3. Next 15 minus 3. 12 minus 3. Nine minus 3. 6 minus 3. And 3 minus 3. After 3 minus 3, if you try to subtract 0 minus 3, it will get a carry. So how many times we have to perform the subtraction? 1, 2, 3, 4, 5, 6, and 7. 7 times. Now let us write the program and check the result. So first load the number, load HL pair, load immediately HL pair with 8500. That is 8500 contains the divisor 03 and 8501 divided. Now move that to B. So B become M. The contents of the memory location presented by HL pair will be loaded to the register B. Now B contains device. Now we'll consider the register C and initialize with 0, 0. So that we can store the position and C. Next, increment H. Now HL pair will be incremented to 8501. Now move A comma M. That is, move the contents of the memory location presented by the HL pair, that is 8501, which contains 15. Move that to the accumulator. Our accumulator contains. Compare B. Compare B subtracts the contents of B from A and sets the carry flag. So it subtracts accumulator minus B, contents of B, and set C carry. So here it is accumulator consists of 15. B is 3, 15 minus 3, there is no carry. If there is carry, we so when will it get a carry? When compare operation, it performs the subtraction and sets the carry flag, but it does not save the value. So compare B will set the carry flag if there is a carry. When will we get the carry? Only when we perform 0 minus 3 until 0 minus 3. So in all the cases of the comparison, it doesn't result in the carry. So if there is carry, if there is no carry, what we have to do is subtract. That is, perform the subtraction. So the contents of P, that is 3, will be subtracted from contents of accumulator, that is 15. 15 equivalent is 21 in decimal, 21 minus 3. Next. So after the performing the subtraction, increment C, because we are storing the quotient in C. So how many times the subtraction takes place, that value must be stored in the C. So for the first subtraction, first time, it will be incremented to 1. Now, jump. Where we have to jump, we have to perform this operation until we get the carry flag. So next is here. We have to repeat this process. Once the if there is a carry, obviously, then all these instructions will be skipped. Then we'll get the result in the accumulator that we have to store it. So that store the result in some location 8502. And now we have to get the C value, A comma C, and store that in another memory location 8503. So in the first case, also we'll check this loop. In the first case, it is 21 minus 3. There is, if there is carry, you have to store the result. There is no carry. So it performs the subtraction 21 minus 3 and increments the C register 1. Jump next. So it comes back again. Again, it performs the comparison because after 21 minus 3, after the subtraction, we hear the accumulator contains 18. 18 minus 3 performs. There is no carry. Again, it comes back. 18 minus 3, it gives 15, and it will be incremented to 2. Jump next. So this will be repeated until we get 0 minus 3. Once you get 0 minus 3, carry flag will be there, and then the value that is on the accumulator will be stored. So what will be the result when that will be in the accumulator? 0, because 0 minus 3, last operation. So 8502 contains the remainder, that is 0, 0. And C will be incremented. Set of after all the subtractions are over, the C value will be 7. Obviously, 7 subtractions has to be taken place to perform the subtraction of 15 and 3. And that's why C will be 7. So more than to accumulate and store in 8503. So 85037, that is the coefficient. So this is a simple program to perform division of two 8-bit numbers. I just once again repeat, the subtraction division is a repeated subtraction. So first take the divisor in 8500, dividend in 8501. Remember, these are the hexadecimal numbers. So you can convert, you can check the equivalent decimal numbers. 3 is equal to 3, but 15 equivalent to 21 decimal. So if you perform the subtraction, see how many times we have to perform the subtraction to get 0, 7 times. So same thing we have written in the group 1. So get first 8500 in HL pair, address in the HL pair. Then move the contents of HL pair, that is the contents of 8500 to B. So the divisor is in B and dividend is in accumulator. And C is initialized to get the quotient value. So increment H, move A, comma B. First we keep comparing. Compare, and if there is a carry, that is the final result. If there is no carry, after comparison, we have to perform the subtraction, and for each subtraction, we have to increment the C value to 1. So this has to be repeated until we get the carry. When will we get the carry for a subtraction? Once the contents of accumulator becomes 0 and B is always 3. So 0 minus 3, the last state it is carry. 0 minus 3, they will get a carry. So immediately it moves. So A consists of 0, that will be stored. And C, because when we got the accumulator 0 after 7 subtractions, so C becomes 7. For each subtraction, it will be implemented and it will be 7, and that is moved to accumulator and it is stored in 8503. So it's a simple program to divide two 8-bit numbers in the microprocessor. So let us write the codes. We'll start with 8000. So as we all know, the LXI H8500 is a 3-byte instruction. So the opcode is 21, 21, 00, 85. Next 8000, 8001, 8002, 8003. Move B, comma M is a single byte instruction and so opcode is 46. Next is 8000. MVI C has opcode 0E and it is 2-byte instruction, so it is 0, 0, 4, 5, 6. Increment H is a single byte instruction and it has opcode 23. Move A, comma M is also a single byte instruction and its opcode is 7. And compare B is also a single byte instruction and its opcode is B8. So it is 8008. Next, 8009. We have JC loop is a 3-byte instruction. JC is DA and loop has to go to store. So let us first count the memory location of this. So it is 3-byte 9 A, B. This next is C. This one is D. Next is 3-byte E, F 10. This will be 11, 11, 12, 13, 14, 80, 15, 15, 16, 17, and 80, 18. Now the loop is to here, that is 11. So TA 11, 80. Next is a single byte instruction SUBB. So it output is 90. And increment C is also a single byte instruction and its output is 0. Jump next. And next we have to give the address. So it's a 3-byte instruction for jump. Output is C3. And we are jumping to the next, that is 0880. Next, store 8502, STA is 32, 0285. Next, move A, comma C is a single byte instruction and its opcode is 72. And STA 8502, 3-byte instruction, STA 32, 0385. And hard 76. So this is the division of two 8-bit numbers. Division is nothing but repeated subtraction, because 8085 does not contain any instruction for multiplication and division process. So multiplication, we have to use the repeated addition process for multiplication. Similarly, for division, we have to use repeated subtraction process. So take the divisor in 8500, divided in 8501, and then 8502 contains the remainder, and then 8503 contains the quotient. So this is the. So remember, we are giving the numbers in hexadecimal. We have to convert. We have to check we can know what is the value. So C is 7, we got the equation. How we got that you can convert in decimals and perform the subtraction. So 7 times in order to perform the subtraction. That's why each time we are subtracting the contents of B from accumulator, we are implementing C. Right? So this is the, I hope you all understood. Please do watch video by uploading and execution. Thank you.